So we're going to be calculating the volume of cubes and cuboids today. To be successful, you're going to use your previous knowledge of 3D shapes and their properties. You're going to use your knowledge of multiplication and working with a formula again, and you're going to apply all that knowledge to solve problems. So how would you describe volume to an alien? If you were in class, I'd ask you to do this with each other and pretend that you are aliens. But as we're not, I've got to give you the definition of this. So the volume is the measure of the amount of space inside a solid figure, like a cube, a ball, a cylinder, a pyramid, and all of these are 3D shapes. So the only shapes that can have a volume are 3D shapes. We're moving on now from 2D to 3D. And 3D has, it says it in the name, 3D stands for 3 dimensions, which means the volume will need its height, will need the base, and will need the depth. Height, base, and depth. 3 dimensions today. So volume is the space within inside a 3D shape. In problems, sometimes we'll be asked to calculate the volume of a shape that looks like this. Now it is important to remember that unless it's stated within these problems, one little cube, so let's do my first one in red here, one of these cubes will be 1 centimetres cubed, and this time with area that you've been looking at recently, we're working in centimetres squared. This time it is centimetres cubed because area has volume. Area has 2 dimensions and volume has 3 dimensions. So that's why it's centimetres cubed. So one of these cubes is 1 centimetres cubed. So I have one there. I can see that I have another one there, 2. I have another one here, 3. And I have another one here, 4. So my answer here will be the volume equals 4 centimetres cubed this time. Let's have a look at a little bit more complicated ones. That was really easy. Calculate the volume of this shape. So let's have a look. I have 1 cube, 2, 3, 4, 5, 6, 7. I need to notice that it does include the side bits there. 8, there, 9, 10, 11 would be this one, and then you need to include the bits at the top, as that would be a cube. 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 12, yes. So the volume of this one will be 12 centimetres cubed. And as you can see, it does take even me a little bit of time, and I'm standing about 2 metres away from the board trying to figure it out myself. Sometimes it can be a little bit trickier, and sometimes we have shapes where some of the cubes are hidden. For example, in this bottom left one, I can see that there is 1 cube there, 2 there, 3 will be this one on the bottom here, 4 there's another one on the bottom here which includes that whole side there, 5 here, and 6 there. But what I do need to remember is this cube here must be sat on something, otherwise this one and this one would just fall down. So there must be a cube hidden underneath here as well. So I can see 6, 1, 2, 3, 4, 5, 6, but I must have one underneath as well. So the volume of this one will be 7 centimetres cubed. And if you were in class, I would get you to make this without that one that's hidden underneath that these 2 here are resting upon, and I would show you that there would have to be one there, as it would just fall down. Unfortunately today we're going to have to just do the best we can and try and visualise this as best we can. Now there is another way of calculating this, and you can see on the one on the right that there will be quite a few missing shapes on here. So the best way I'm going to look at this is think, right, let's just look at this bottom half here. How many do I have? I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. But I must be missing some. So let's just have a look at this area part. This front bit. This front bit is 2 high and 4 along. So this must be 8. And then I can see at the back that I have another row of that there. So it must be 8 at the front, 8 at the back, making 16. And all I need to remember is to add 1, 2, 3, 4, 5, 6, 7, and I can just about see 8 there. So 16 add 8. This one must be volume 24 centimeters cubed. That's a little bit of a tricky one there. What I'd like you to do now is to have a go at task 1. See if you can calculate the volume of these. Then have a go at task 2, see if you can apply that knowledge to some mastery tasks. When you're ready for task 3, come back to the video. Right, task 3 then. In problems, sometimes we will be asked to use a formula to calculate the volume of shapes. So let's go over what volume is again. It is the measure of the amount of space inside of my shape, my 3D shape. And in order to calculate the volume of that shape, I need to find first the area of the rectangle at the front, its face. And once I've found the area of that, I can then multiply it by how deep the shape is. Going this way, how deep it is, its depth. So the formula to find volume is its height times its base, which would get me that purple shaded rectangle, and then I'm going to multiply it by its depth, and that will show me this rectangle all going back this way. Okay, so calculate the volume of this cuboid down here. So let's find now the white face, the rectangle. So volume equals its height times its base, and then we will be timesing depth. So let's find first the face, that rectangle there. So that will be height is 5, base is 10, and then I'm going to be multiplying that by its depth. So multiplying that by 2, so its volume must be 5 times 10 is 50, times 2, 100, and this time I'm working in inches cubed. Let's have a look at one more here. This one, my shape has been rotated slightly, so I'm going to have to picture this in my head a little bit. So first of all, volume is height times base times its depth. So let's try and find this white, well now shaded blue, face there, the rectangular face. So volume equals 13 multiplied by 20, and then I'm going to multiply that by its depth, multiplied by 5. Now in this case, because in multiplication I can do them in any order, it might be easier to multiply the 20 and the 5 together first, making 100. So now I know its volume is 1,300, and this time I'm working in feet cubed. Oh no, clicked on the wrong one, sorry. So your task now, what I'd like to do is to now calculate the volume of these cuboids, and there is a cube in there, a couple of cubes in there actually, and I'm sure as you've already seen, answers are all at the bottom.